Hi, 12, this is Mr. Lim here again, and this is going to be our fourth video on volumetric analysis, the actual titration. It's going to be a long one, so strap your seats in. So we're going to learn about how to do the process of titrations, and I don't just copy and paste PowerPoints, honest. All right, so the process starts with cleaning everything, okay? So the idea is that because we are trying to determine the concentrations of substances to a very high degree of precision, so that's like to 3 or 4 or 5 decimal places, very small changes in concentration will make a difference, right? And that's even just by the addition of just a few drops of water into a large amount of solution, and that will make a difference, all right? So to clean something without water then, because remember it's the water that will dilute, which will make it the issue, and make the concentration inaccurate. So the water will make the concentration inaccurate. You can clean the glassware with solution that it needs to be holding. Okay, so effectively you clean it with the solution, and so therefore it's clean of any impurities, but any leftover droplets will be of the same concentration that it's supposed to be at, which is kind of useful, right? Not all glassware needs to be cleaned with the solution it is holding, as some pieces of glassware need to have the exact volume of a solution, and thus, or actually that shouldn't be volume, that should be number of moles. Whoops. Exact moles of a solution, and therefore can't be cleaned with the solution that it is going to hold. So effectively what that's saying is that some pieces of equipment, that's especially of a conical flask, the idea is that there has to be the correct number of moles in there. And so if you have any extra droplets of that solution, you've got the wrong number of moles. Okay, so some pieces of equipment you need to have the right concentration. Some pieces of equipment you need to have the right number of moles. Okay, and that will determine what you clean your substance with. All right, so the following substances pieces need to be cleaned with the solution it will hold. Only the pipette and the burette. Okay, so the pipette, before taking the desired volume, must be cleaned with the solution so that there are no drops of water to dilute the sample that must go in there. Okay, because you want to keep that concentration absolutely accurate. Same with the burette, clean with the solution so that it's not diluted by any water. All right, so that you keep that concentration correct and accurate. The following pieces need to be cleaned with water. Okay, that's the conical flask, and this should be really distilled water. Okay, conical flask can't have any extra reactants in it. All right, so if any extra reactants, that'll change how much you need to react with it, so it's not very great. All right, so you use water to do so, and you can continue to add water in there for as much as you need. It won't make a difference. All right, and beakers holding the solution. Okay, so these beakers that are holding the solution should not be, they should be cleaned with water and not the solution, because they have to hold the solution, right? So they can be cleaned with water prior to use, but they have to be absolutely dry, so that the concentration of the solution isn't diluted. All right. Why can't you do that with the pipette and the burette? Because the pipette and the burette are very skinny, so you can't get that dry in a reasonable amount of time. All right. But the beakers, you can dry it with a piece of paper towel, and that means that the concentration won't change, and that's useful. Okay, so preparation. So once you've cleaned everything, you need to get everything ready. So solutions being used in the titration are collected in the clean, dry beakers, all right, and used for cleaning the stuff. Okay, so you actually have to go and collect the solutions, your 2 solutions, and then use it to clean the burette and the pipette. Okay, once everything is cleaned, all right, the pipette is then used to collect one of the samples, because remember, one of them is your known, one is your unknown. So the pipette is going to hold one of them, and I'll usually tell you which one it is, or the question will tell you which one it is. You don't have to decide. One of the samples, and then it is delivered to the conical flask. So again, the pipette collects a specific volume, and that specific volume is delivered then to the conical flask. Right? Remember, at the end of the pipette, you're to leave that tiny little bit of solution there. Okay, so pipette. That's how you draw one. Okay, you take it out from your beaker. Here's your solution of one thing, right? Fills up your pipette. Okay, well, first of all, you clean it and then you fill up the pipette, and we'll go through the cleaning process in class. All right, then you bring it over here and you drop it into the conical flask, which will then have your solution in it. Okay, so you'll transfer just a small amount. Okay, so normally this would be about 150 or about 100 mils, but you'll only normally collect around 20 in the pipette, and then you'll deliver 20 mils or so into the conical flask. Right, which solution is in the pipette and which solution is in the burette can vary, right, but it is determined by the color change of the indicator. Whichever combination produces a color change that is easier to recognize is the way that you do it. Okay, so if it goes from, if red to blue is easier to notice than blue to red, then that's the way that you'll do it. But you don't have to worry about that one, really. All right. So you get your pipette, you collect one of those solutions, you drop it into the conical flask, which should all be dry, or clean at least, with distilled water. Then what you're gonna do is you're gonna clean your burette, okay, and then, oops, that's not what I want. Here's your burette. And here's your thing. So the burette is filled to a value between 0 and 5 mils on the burette scale. Okay, so remember there are graduations all on this thing. Okay, and so you fill it up. So you pour it in. Now normally you will have to make sure that your tap is closed. Right, so you close that tap, close it, then you fill it up, okay, with that solution after you've cleaned it. Remember, after the tap won't have any solution because you've closed the tap. So what you do is you get your waste beaker, first of all, your waste beaker, and then you open the tap, and then it will flow through a bit, and then it will collect in your waste beaker, and then you close it again. So now you have the entire burette ready to go, right? Full of solution all the way to the bottom, right? And you need to make sure that you read it after you've filled it up again. So remember, you've just gotten rid of a little tiny bit because a little bit went below the tap, okay? And so whatever that value is, now you read it, and that is your initial, and that's what you're gonna do, all right? So remember to release it into the waste beaker, not into the conical flask either, okay? And that initial should be between 0 and 5 mils because 0 is at the top and 50 is at the bottom. Okay. The indicator is added to the conical flask. Indicator is generally a weak acid, and we dealt with indicators in the last topic. So the more you put in, the more the indicator will affect the reaction. So you need enough indicator to see, but not enough to make a difference. So generally, we do 3 to 5 drops of indicator into your conical flask. Okay. So right now you should have your burette with your solution in it, okay, all the way through. Then you should have your conical flask with your other substance, other solution, and you should have a few drops of indicator in there, and that should be mixed around so that it makes it change color. All right. So the actual titration. So the initial volume on the burette is recorded to the best of your ability. Okay, technically you're supposed to be able to read to the next decimal place on an analog scale. So what that means is that because the scales are, oops, I should probably have that in pen. The scales are, 0.1, 0.2. They don't actually say these things, but you should be able to work out what they are. 0.4. You're supposed to be able to read if there's a value here, like 0.34, okay? And this value is supposed to be any value on an analog scale, but in reality, this value can probably only be between either 2, 4, 6, 8, or 0, okay? So that's how you would try and read it, and we'll practice that in class. So first of all, you record the initial volume, right? Then you open your tap on your burette, and the solution is allowed to flow into the conical flask and mix in. The solutions, when mixed, will react, okay? And then will eventually, when the sufficient solution is added from the burette, the solution in the conical flask, it will completely react and the indicator should change color. So effectively, again, I probably shouldn't have done this in multiple slides. I should have done it in one slide so I could go back to this thing. Here we go. Here's our burette. Here's our conical flask. The red substance is in the conical flask. The blue substance is in the burette. And it's dropping down. Okay? So what you should recognize is that I'm slowly removing or lowering the volume on this burette. And that means that the amount of stuff in here is getting more and more and more, okay? And at some point, it will equalize, all right? And there'll be the same number of reactants to each other, and then they'll change color to something else. And then you'll be able to like, oh, I should stop the reaction, all right? When you stop the reaction, you should take the final value, and then you'll be able to work that out. So the initial takeaway, the final will be the difference, or the final takeaway, the initial will be the difference, and that'll be the amount that you delivered into the thing. Okay, so here's a couple of tips. The first titration is generally a rough titration, which means that you need to get the rough amount you need to get the color to change. Okay, so you ideally want to get the exact right amount delivered from the burette into the conical flask. Okay, you don't want to go too much, you don't want to go too little, otherwise that's not going to be accurate. So to get the just right amount, you need to, effectively, it could be one single drop and you'll get to the right amount. And then another single drop will bring you over that amount, and that'll be not good enough, right? So you want to get like a color change on a single drop, okay? However, that's there'd be no point to add it drop by drop by drop for the very first one, because that would take forever. Okay, so like imagine you have to do 20 mils in drop by drop by drop, and each drop is 0.04 mils, you'll be there forever. So the idea is to say the first one is that I'm going to get the first one wrong, but it'll give me a general idea about how far I need to go. So what that means is that, okay, here's my burette. I'm dropping in the solution, okay? The solution goes down, 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 right? And then I'm definitely going to go over, right? Because I'm going to add it and not really add it slowly. So when the color changes, it's going to have a little bit too much. So if I say that I started at like 2.8, and then I ended up at, I don't know, like 23.2, right? 23.2, 2.8, 4, 0.2, 20.40 mils, okay? That means that 20.40 mils was too much, right, for my first one. So what then I would say is that, okay then, if I'm going to do the next titration, actually we'll go what we do with the next titration in a moment, all right? So, you do it quickly so that you can get the definite color change. You swirl while you're doing it, all right? Because you're adding it quickly, the first titration will generally be too much solution from the burette. Once the color change has occurred, the stopcock should be closed, okay, so that you can get the final value. Final volume on the burette is recorded, that's that 23.2. The difference between the initial and final values is the volume delivered, and is known as the titer. Okay, so you should know this word, the titer. That's the volume that's delivered. All right, so we've just gone and done our rough titration. We went from 2.8 to 23.2. That means we've added 20.40 mils, and I wasn't really very fast at stopping that burette tap. And so I know that it's going to need to be less than 20.4 mils for the next one, all right? So the second and subsequent titrations should be focused on being more accurate with the volume. So then I don't because I want one drop to change the color, I need to make sure that I'm adding a single drop at a time and then checking if it changes color, all right? But I didn't want to do all of that, let's do entirety of 20 mils all in one drops. So I did the rough titration, and my rough titration told me that it's roughly 20.4 mils, okay? So if I started on my burette at 23.8 mils, and this scale goes all the way to 50, I know that I can go down, my solution here, I can go down and add, not that one. I can go down in volume all the way roughly to about 20, so just less than 20.4 mils. So that would be like 42-ish mils, all right? Before I need to do it drop by drop. Okay, so I would add 23.8 all the way to 42 very fast, and then I would do from 42 onwards, drop by drop. Okay, so what does that say? What does that mean? So what you've done, you've worked out where you want to stop that delivery of fluid just after the color change occurs, or before the color change occurs. That means you take the volume of the rough titration, which was the 20.40, and subtract a few mils. That was like subtracting 1 mil or so. Then use it with your initial volume, which is the 23.8 on your burette, to work out a volume on the burette where you should slow down your addition. So you do fast, all the way through here, and then you slow down at 42 to do it drop by drop. Okay, so we call this drop by drop. Okay, you continue until the color change has occurred. So you go drop, did it change color? 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 All right. So then the next titration might give me, oh yeah, okay, I went drop by drop, and I got a value of 20.28 mils. Okay, which is good. That's my titer, my difference between initial and final. So I see that it's a little bit less than my rough one, so I can be looking to get around 20.28 again. All right, you record your results in a table. You keep track of the volumes delivered. Okay, you continue to perform titration, so you keep on going. So effectively, you refill the burette, you refill another conical flask with solution until you achieve concordant results. What does this word concordant means? Concordant results means when you have added volumes that are 0.1 of each other, meaning that they have a range of 0.1 and not one value plus or minus 0.1. Okay? So if I said that my, let's do this. This was my T1, my rough one. My T2 is over here. My T3 would be 20.24, and my T4 would be 20. See, I screwed this one up. 48. Okay. What I could say is that these two, let's do it green. These two are within 0.1 of each other. All right. But this one is not. Okay, so I can't use that one, so I'd have to do this titration one more time, T5, and I might get 20.1 or 20.20. Okay, 20.20 is again makes all three of those values within 0.1 of a mil. All right. So it has a range of 0.1, so I'd be able to say, okay, those three are concordant values. I'll take an average of that for my calculations. Okay. Once you've done the titrations, and we'll go through calculations later on, but once you've done the titration, you've got your results. You have to clean all the equipment. What do you clean the equipment with? Everything is with distilled water, and then you invert and revert to stand. Okay. The burette with distilled water. And then make sure you clean below the stopcock, and then invert, which means turn upside down and return to the holder. Conical flask, twice with tap, then once with distilled. Same with the beakers, twice with tap water, once with distilled water, and then you put them away to dry. Okay, so that's the process, and we're going to go have a try of it, but we'll see how you go, and hopefully that helps your understanding. Adios.